So this is our second recording on nanotechnology. So if you haven't listened to the first one, I recommend you go and listen to that first. So nanoparticles have special properties because of their very high surface area to volume ratio. Now, as particles get smaller, their surface area to volume ratio will increase. So decreasing the length of a cube, for example, will increase the surface area as it goes smaller. So if you decrease it by a factor of 10, that increases the surface area to volume ratio by a factor of 10 each time. And smaller quantities of nanoparticles are needed because of this. So comparing it to normal sized particles, you need less nanoparticles, which means that they're cheaper and more efficient to use. And changing the properties of a material, they completely change once they become nanoparticles. So if you think of normal gold particles, gold is very precious and it lasts a very long time because it's very unreactive. But when gold becomes a nanoparticle, it becomes an incredibly efficient catalyst for many processes. So it behaves very differently. Now, just to recap that, small particles have a higher surface area to volume ratio. And normal gold particles are extremely unreactive. But gold nanoparticles can be very efficient catalysts for many processes. And some of the uses of nanoparticles is so nanoscience is a really important area of research in chemistry. And currently we use nanoparticles for catalysts because they're very high surface area to volume ratio means that larger surface area will help reactions be catalyzed easier and they'll speed up better. They're also used in medicines. So, for example, fullerene, which is something that has been discussed in a previous episode on carbon structures. Fullerene is actually a nanoparticle, and it can be used to effectively deliver drugs to specific areas of the bodies to help target disease. So carbon nanotubes is another structure we've talked about in the carbon structures episode, and they're used in computer chips. They're another example of a nanoparticle. And nanoparticles are also used in cosmetics a lot. So these are small, so small that visible light passes through them, which makes them transparent. That's why a lot of creams and things become transparent. So for example, white substances like sun cream, they can be made transparent using nanoparticles. So I'm sure you've seen the clear sun cream that you can buy instead of the white sun cream nowadays. It can also be used as a deodorant. So nanoparticles have an antimicrobial property, and they can be used in deodorants to make them more effective at killing the bacteria that generates bad smells under your armpits. So to recap some of those uses of nanoparticles, they can be used in medicine, cosmetics, electronics, catalysts, and as deodorants. Fullerene nanoparticles can be used to effectively deliver drugs to specific areas of the body to help target disease. And which type of gold particles can be used as catalysts? Now remember, regular gold particles do not react, they're very unreactive, they can't be used as catalysts. But if you use gold nanoparticles, they are very, very effective catalysts and they behave very differently to regular gold particles. And fullerene nanoparticles can be used to deliver drugs to specific parts of the body.